All right, the very first lesson of Math 20-1, Inductive and Deductive Reasoning. So it's the reasoning unit, and we're looking at different ways that we can prove things, come up with reasoning, come up with conjectures, mathematical conjectures. So we're going to go through a bunch of different examples. So the first one, just looking at a number trick. So something that sort of steps that you've been told to do, and see if we can come up with a pattern, what always happens when you do these particular steps, and come up with what we call a conjecture. So in this first one, do the following steps for 4 different numbers. So it says pick an integer. So maybe you want to just start with a nice integer like 1. So then it says add to this integer the next 4 consecutive integers. So this is a good word to learn. Consecutive means in order, up by ones, okay, or a difference of 1. So in this case, next 4 consecutive integers. So we start with 1, then we would add 2, 3, 4, and 5. The next 4 consecutive. Add those together, so that's 3 and 3 is 6, plus 4 is 10, plus 5 is 15. Then divide that total by 5. Well, 15 divided by 5 is 3. And then subtract 2 from that. We get 1. Well, what's significant about 1? Not much. It's an integer as well. Turns out it's the same as what we start with. So we're going to figure out if maybe that happens with any integer. So let's try next one, maybe a negative. Let's see what happens here. If we chose negative 3, maybe I'll choose a different color. So if I choose negative 3, then negative 3, the next 4 consecutive, that means I have to add negative 2. I'm going to change to skinnier here. Just give me a sec. Here. So negative 3 plus, okay, next 4 consecutive, we have to keep increasing by 1. So negative 2, negative 1, 0, and 1. Okay, if we add those together, that's negative 5 plus negative 1 is negative 6, plus 1 is negative 5. Take negative 5, divide by 5, we get negative 1. Take negative 1 and subtract 2 from it, we get negative 3. So we do get the same as the original. Okay, so pause the video. You do 2 more trials yourself. Okay, so I chose for trial 3, starting with 2, for trial 4, starting with 0. Both times I end up with the original value that we started with. Okay, so what conclusion can you make? So the resulting integer is the same as the original. Okay, so Sam also tried this number trick with 15 different numbers, and each time he did the trial, he always ended up with his original number. Even though Sam did not try it for all numbers, based on this research, he generalized that from these specific examples to all numbers and made the following conjecture. So conjecture is a math word. It says if you did this number trick on any integer, you will always get your original number. That's his conjecture. So it's an if-then type statement. So it says, so the definition, a conjecture is a statement that you believe to be true, although you have not yet proved it. This is an example of inductive reasoning, which involves making a general conclusion from several known cases. Inductive reasoning goes from the particular to the general. Okay, so basically inductive is you're looking at a whole bunch of trials, a whole bunch of examples to come up with a conjecture. Okay, then you're going to want to prove it. Okay, so Sam is convinced that his conjecture is true and wants to be able to prove it. He knows that he cannot prove it by trying every integer because there's too many of them, infinitely many. Instead of trying each specific, how should he proceed? So best way is to represent an integer, right, the original, with a variable. Okay, and then see what happens. So it says use your algebra skills to prove that Sam's conjecture is true. So we want a let statement. So let's let x be the original integer. Okay, so then what did we do in the steps? So then you go through each step of what you were asked to do. So it says pick an integer, so we've got that. Add this integer to the next 4 consecutive. So we start with x, then we want to add the next 4 consecutive. So that would be x plus 1 plus x plus 2 plus x plus 3 plus x plus 4. That's how you show any set of consecutive integers. You keep adding 1. Okay, so what do you get when you do that? So that would equal 6 x's plus 3 plus 3 is 6 plus 4 is 10. Oh, sorry, not 6 x's, 5 x's. 5 x's plus 10. Okay. And then it says take that and divide by 5. Okay, so algebraically, divide each term by 5. We end up getting x plus 2. Then it says take that and subtract 2 from it. So this is really the first step, second step of the number trick, third step. And we get x. So we started with x and we ended with x. So that proves it, right? So this is the original number. Integer, I guess, in this case, right? Although you can see it would work with any. Because of this deductive proof, x could be anything. Okay? Now, saying that consecutive, really with fractions or decimals, we don't talk about consecutive decimals and fractions. So it could be whole numbers or integers. Okay? So to prove a conjecture, one must use deductive reasoning, which is showing by means of a logical process that what is to be proved follows from certain previously proved or accepted propositions. Those are all the laws of addition, subtraction, division with algebra. Okay, those have already been proved. So that's one example. Let's take a look at the next one. Prime numbers. So mathematicians have been trying, so just to back up here, a prime number is a number that has exactly 2 factors, one in itself. So that's a review. You should all know what prime numbers are. Mathematicians have been trying to determine an expression that will always generate a prime number answer when a natural number is substituted into the expression. Sam came up with the expression n squared plus n plus 17. Test to see if this expression generates prime numbers by evaluating the expression for the following natural numbers. The first 3 have been done for you. So pause the video and do that. Find the value when n is 4, 5, all the way up to 11. Okay, so hopefully you check your answers with what's there. And then it says, did you always end up with a prime number? So if you check all of those numbers that you got, they are all prime numbers. So you should have seen that the expression did work for the first 11 numbers. Complete the following conjecture. So it's, as I said, it's if or when something happens, what's the result? So if then, or in this case, when then. So here, when any natural number is substituted into the expression n squared plus n plus 17, then the result is a prime number. What kind of reasoning was used to make this conjecture? Inductive or deductive? Well, we looked at all of these examples. So examples are inductive. Do you believe this conjecture is true? If you believe it to be true, write a deductive proof to show that it will work for all natural numbers. If you believe it is not true, provide a counterexample. So find an example that does not work. And that's really what happens with proofs. You either, to prove it's true, it has to be true for all situations. There cannot be just one case that doesn't work. If there is one case or more, then that's a counterexample. And so all you have to do is provide that counterexample, that example that does not work, and then you've disproved it, basically. So a proof requires a whole lot more work sometimes than a counterexample when it doesn't work. Okay, so take a sec, think about it. Think about if you've heard about prime numbers, and if you've heard that there's a way to generate it. Probably maybe if you're really interested in math, you've read on the internet or researched different types of numbers. There isn't a way. There isn't just a nice, in this case, algebraic expression like that will give us all prime numbers. So there is an exception. So think about what value of n could you substitute in there to give you a counterexample. So that would mean to give you a number that is not a prime number. Okay, so think about that. Pause the video if you need to. Really, if you think about it, if n is 17, then all of these terms will have a factor of 17 in them, which means you can factor it out. Okay, so based on, back to math 10, right? Factoring is a common factor to all the terms. 17 would be that. So if we let n equals 17, then we'd have 17 squared plus 17 plus 17. Well, the last one isn't in brackets because it was part of it. If you enter that into your calculator, or you can think about it, you're factoring out. If you think about back to algebra, if you factor out 17, you're left with 17 plus 1 plus 1. So 17 times 19. Okay, so obviously, and that number is, what is 17 times 19? That's 17 times 19 is 323. Okay, so we just found a number that's generated with that same expression that's not a prime number. We call this a composite number because it does have factors where one of them is not 1. Okay. All right, so that's an example. So we've now found this is a counterexample, n equals 17. So we don't have to do a formal proof because we can't prove it. Pythagorean triples says show that the numbers 3, 4, and 5 satisfy the Pythagorean theorem. 3 numbers that satisfy the Pythagorean theorem are called a Pythagorean triple. If they were sides of a right triangle, if you have 3 numbers that satisfy the Pythagorean theorem, they could be the lengths of the sides in a right triangle. Okay, so anytime you're doing this, anything with the Pythagorean theorem, C represents the longest side, the hypotenuse. In this case, it would represent the biggest number. So I like to do proofs like this, left side and right side. So in the left side, I'm going to put the biggest number, and I got to square it. The right side, I put the smallest numbers, sum of the squares. So left side equals right side. It's a Pythagorean triple. Then it says multiply 3, 4, and 5 by the number 2, and then see if that works. Well, that would give me 6, 8, and 10. So in my left side and my right side, I would take the largest one, 10 squared. Right side would be 6 squared plus 8 squared. And it works. Then it says repeat the process by multiplying 3, 4, 5 by the numbers 3 and 4 and showing that the new set of numbers are also Pythagorean triples. So pause the video and you do that. Okay, so check your answers for 9, 12, and 15, 12, 16, and 20. And then next one says, do you think that if you multiply 5 or 6 by or k, So multiply by 5 or 6 or k that you will get a Pythagorean triple. So based on this, all of these examples, I do think I would. Okay. And then it says write a conjecture based on your findings. So I would say if you multiply each of the numbers in a Pythagorean triple by any number, you will still get, or I should say the result is still a Pythagorean triple. Okay, so then use deductive reasoning to prove that your conjecture is true. So we're going to let k be, it could be any number. Okay, we'll let, so therefore, the Pythagorean triple, I'm going to abbreviate it, would be 3k, 4k, 5k, and then we'll do our left side, right side. Sorry. So left side would be the largest, so 5k. Make sure you put that in brackets. So that's 25k squared. If you don't put it in brackets, then it would be 5k squared, and that wouldn't work. Right side would be 3k in brackets squared plus 4k in brackets squared. And that's 25k squared. So left side equals right side. Okay. All right, so we've just proved it that way. Another example, number patterns. Complete the following calculations. So do this. I want you to try this without a calculator, right? So common denominator would be 6. So that would be 3 6 minus 2 6 is 1 6. Common denominator would be 20. So that would be 5 20ths minus 4 20ths. Common denominator is 12. 4 12ths minus 3 12ths. Common denominator is 30. 6 30ths minus 5 30ths. Oops, I forgot to finish these off. So that's 1 12. That's 1 30th. So look for some patterns here, right? So examine your results and use inductive reasoning to predict the results of the following. So I'm not going to actually calculate them by hand. Look at what happens here. So I always end up with a numerator 1. How are the original fractions related? Well, the numerator is 2 here, then it's 1 more than that in the what you're subtracting by. 4, 1 more than that. 3, 1 more than that. 5, 1 more than that. Okay, numerator's all 1, and they're all subtractions. So here, when I see this one, the new denominator is the product of the original denominator, so that would be 42, and I'd have 1 up top. Here, this would be 56, 1 up top. Then, now we want to check to see if our predictions were true. So that would be 42, so that would be 7 42 over 42 minus 6 over 42, which is 1 over 42. Then here, 56, 56, subtraction, 8 over 56 minus 7 over 56 is 1 over 56. Okay. So, what's the conjecture here? So in general form, so 1 over n, that would be like 1 over 6, minus, then 1 over, what's 1 more than n? It's n plus 1. So that's your original expression in general. What do we end up with? 1 over the product of the two denominators. Okay. You could show that as 1 over n squared plus n if you wanted to, but really it's 1 over n times n plus 1. So then it says use deductive reasoning to prove your conjecture. Well, we've already, so basically we want to show, remember we've learned about rational expressions, and we want to show our work. So we're starting with really our left side here, 1 over n minus 1 over n plus 1. We need a common denominator, so n times n plus 1, which means the numerator here has to be n plus 1, because we're multiplying top and bottom. Then minus, same denominator here. This we have to multiply top and bottom by n, right? So that'll be just n. Okay, then really we've got that common denominator. So we're taking n plus 1 and subtracting n, which is 1. Okay, and that's what we said. Okay, that's what the result is that we thought. All right, so that's another example. Next one, into some geometry types of applications. So sum of the interior angles of a polygon. This is something that you should already know from junior high, but you might forget some of the bigger shapes. So Sam drew several triangles, quadrilaterals, pentagons, and hexagons. For each polygon, he measured all of the interior angles and found their sum. The following table shows his results. Okay, so triangle, hopefully you remember it adds to 180. Quadrilateral is 4 sides, 360. Pentagon, hexagon, etc. Look at the pattern that's given here. So 180 times 1 is 180. 180 times 2 is 360. 180 times 3 is 540. 180 times 4 is 720. So use that pattern to fill in the rest of the values there. Okay, so it says use inductive reasoning to complete the rest of the table. So pause the video and do that. Okay, so using that reasoning, fill out the chart, so check it. It says write a conjecture by completing the following statement. The sum of the interior angles of an n-sided polygon is 180 times, well, what's this value here? It's not the number of sides. In this case, it's 7 when the sides are 9, 6 when the sides are 8, 5 when the sides are 7. It's 2 less than the number of sides. Okay? So sometimes we actually use the formula. All right? Because this is defined here. N-sided means n represents the number of sides. So we don't have to say anything more than that. It says use deductive reasoning to prove your conjecture. Hint, divide the polygon into triangles by taking only one vertex and connecting it to the other vertices. How many triangles are formed? So for example, maybe you want to do something just to test it out. So that's 5 sides. What that's meaning is take one of the vertices, from there split it into triangles. Well, how many do you get? You get 1, 2, 3 triangles. And you know the angles in each triangle add up to 180. So you need that angle, you need this one plus this angle in here, plus this one in here. Well, those add up to 180, right? So you need all of these. So you're really taking 3 times 180, because each of those triangles have angles that add up to 180, and all the vertices of those triangles are at the vertices of the polygon. Okay, so it's not really sort of a whole algebraic proof, it's more in words. So an n-sided polygon can be divided into n minus 2 triangles by joining one vertex to all the others. Okay, since the sum of the angles, since the sum of the angles of a triangle is 180, then the sum of these are all interior angles, right? We're not talking about exterior. So the sum of the interior angles of n minus 2 triangles is 180 times n minus 2 degrees. So once a conjecture has been proven, the conjecture can then be called a theorem, and the theorem can be applied to other specific situations. So then you can use it, basically. Oops, sorry, what did I just do? There. So it says, use your theorem to determine the measure of the unknown angle. So you want to look here, how many sides? 1, 2, 3, 4, 5. So the sum of all angles will be 180 times 5 minus 2 degrees, so 180 times 3. So 180 times 3 is 540. And they all have to add up, right? We're only missing one angle. So therefore, x plus 130 plus 112 plus 155 plus 78 equals 540. And solve for x. I guess we'll collect like terms on the left. So x plus 475 is 540. X equals 65. If you don't want to leave the degree symbol, if you don't want to use it, that's fine. But then at the end, make sure you have it there. Okay. Although in this case, I guess, that's got the degrees there. So really x is 65 because the degree symbol is given. Okay. It says a regular polygon is one where all sides have the same length and all angles have the same measure. Okay, so regular means all the same. What is the measure of each interior angle of a regular octagon? So how many sides is an octagon? Is 8 sides. It's like a stop sign. Okay. So we know that for 8 sides, so sum of angles will be 180 times 6. Okay, so that's going to be 135. Oh, sorry, that's skipping ahead there. 180 times 6 is 1,080. Okay. And then each angle has to be the same. If it's an octagon, there are 8 angles. So if we let's say x be the measure of each angle, then 8 x's equals 1,080. So let x be each one interior angle. Okay, so then divide 1,080 by 8, and we get 135 degrees. Okay. Then determine a formula for the measure of an interior angle of a regular n-sided polygon. So what did we do here? This would have been nx equals 180 times 8. In that case, it was 8, but it's n sides, so n minus 2. So if we just solve for x, it's going to be 180 times n minus 2 over n. And you could put the degree with the 180 if you want, or on the outside. Okay. Then it says determine the measure of angle ABC. So same thing here. Count up the sides. So 1, 2, 3, 4, 5, 6. So angle sum is 180 times 4. Okay, so 180 times 4 is 720. And then we have to add all these together. So just make sure you don't lose track. So I'm going to start at A, so 2x minus 15 plus 2, sorry, I'll go to B next, plus x plus 10 plus 3x plus x minus 25 plus 3x minus 25 plus 2x plus 10. Okay, if you want to keep the degree symbols in there, you can, or you can leave them out. So then collect like terms, 2x plus 1 is 3x, 6x, 7x, 10x, 12x, plus negative 15, plus 10, negative 5, negative 30, negative 55, negative 45, so subtract 45. So you might want to just leave the degree symbols off right now, that's fine. Okay, and then 12x would equal 765. Divide by 12, you get 63.75 degrees. And then it says the measure of angle ABC. So ABC, that would be this one. So therefore, x plus 10 degrees is 63.75 plus 10 is 73.75 degrees. Okay. And then an exterior angle of a regular polygon is 30 degrees. How many sides does the polygon have? Okay, so basically, just make sure this is exterior, right? So exterior means, like if you have something like this, it means if you extend it out, that's exterior. If you extend it out, that's exterior. If you extend this out, that's exterior. Okay? All going in the same sort of direction from there. So basically, we want to get this angle in here. Okay? Oops, it's a regular polygon, so that means these sides will all have to be the same, right? So that means these angles inside would be the same. So we know the formula for that. So interior angle would be 180 times n minus 2 divided by n, okay? Then if this is 30 degrees, that means the interior has to be 150. So 150, because it forms a straight line, right, which is 180 degrees. So 150 equals 180 times n minus 2 over n, and then it's an algebraic equation. So multiply through by n, and again, if you want to drop the degree symbol right now, you can. Bring that over, that's going to be 360 equals 30n, so n equals 100, n equals 12, okay, and yeah, it would be anyway, because this would be 30 degrees, the degrees would divide out, n is the number of sides, so therefore 12 sides. Okay, then last thing to look at, the mathematical process. So kind of there's a flow chart here. Perform an investigation. Use inductive reasoning. Okay, all of those examples to write a conjecture. Then prove it, okay, deductively. And then you've proved it. So then you can use it to answer other problems. Okay, theorem to do actual problems. Okay, and that's it for this one.